Okay, so I've got a y equals, I know it's a rational function, so I'm going to have a top and a bottom. Vertical asymptotes, that must mean I have an x minus 3 on the bottom. Oops, I'm missing an x here. And an x plus 4, right? And on the top, I guess I would have x plus a quarter. And then what is this 0? That's like saying x minus 0, right? Which we normally don't write it as. So I would write it probably as x bracket x plus a quarter all over x minus 3x plus 4. And some textbooks don't usually show fractions, so they might have done something else. Did anyone do anything else with this?
Yes.
Yeah. I would accept this, by the way, but you might have written it, it looks a little nicer like this, 4 plus 1. Yeah, that's what you would usually see in a textbook, to be honest, or on an exam. I think on an exam they would probably tell you to graph it, and they give you this form. Okay, so that's it. We good? Okay, same here. Rational equation, vertical asymptote, a whole, and x-intercepts. Okay, so once again, y equals, so vertical asymptote at x equals 5. I have a minus 5 on the bottom. If I have a whole at x equals 2, what does that mean? I have a common factor, right? So there has to be one on top, one on bottom. And then I also have x-intercepts of 4 and negative 10. So that would be that, right? Okay, what about this one? Determine the equation of a rational function, vertical asymptote, x-intercepts, and it gives me a whole at a point value. Okay, well, what happens here? I've got an x minus 4 on the bottom, x-intercepts on the top, and a whole at 2 comma 1. What do I do with that? I have an x minus 2 top and bottom, right? But they give me more info than they gave me up here. Yeah, they get, what do I do with this 1?
It goes down.
Can I do anything with that 1?
Because you have to cancel.
If I do this, let's just do a check. So these guys will cancel, right? So if I put a 2 in here, let's see, if I put a 1 in where y is, and then I have 2 minus 1, 2 minus 3, 2 minus 4, that should all work, right? So let's see if this works. I get a 1, a negative 1, and a negative 2. Something's wrong here. Why doesn't this work? If they give me more info, you know what that's telling me to do? There's an a value here, right? So I have to use the point 2 comma 1 to find a. They're giving me more info here than they did last time, right? They're being a little more specific. Notice they said possible equation, a possible equation, and this time there's one equation because they're giving me, so there must be a coefficient here, which can happen, right? So I guess what I'll do is I'll find a now. So I'm going to use 1 equals a, 2 minus 1. If they give you a point, plug it in and check. Sometimes a will equal 1, right? But this time there must be an a value. Okay, let's see what a equals. So what do I get? I get 1 times negative 1 over negative 2. So 1 equals a times a half. So a is 2. Okay, so this time there was an a value. All right, so finally the equation is, whoops, y equals 2 x minus 1, x minus 3, x minus 2, all over x minus 4, x minus 2. Okay, that was a little tricky. You've done that skill before, right? If they give you more info, just check the info they give you, right? Everything should check. And if this point doesn't check with the equation, there's something else going on. So maybe there's an A value. Okay, what about number 2? 2 is totally theoretical, right? This really, I think, is designed to, if you know what's going on, it's all theory. Identify the x-intercepts and the equations of any vertical or horizontal asymptotes for the rational function y equals x minus a times x minus c all over x minus b times x plus c. Okay, are there any, there's no common factors, so I don't have to worry about holes. Are there any vertical asymptotes? So what would you say for your vertical asymptotes? X equals b and x equals negative c? Okay. All right. What about x, or horizontal asymptote? Let's do that. 1, right? If I multiplied these out, I would get x squared on the top, x squared on the bottom, coefficient of 1 over 1, which is 1. Okay. How about x-intercepts? A and D, right? Good. How many people got that? Good. Okay. Next one is interesting. Again, comes back to equations and or linear equations and quadratic, something that you talked a lot about in grade 10 and 11, but then we can't forget about it in grade 12. So, write the equation of the rational function shown in each graph. This looks linear, but I know it's rational. You know why? Because of the holes. And this looks quadratic, but it's rational because of the holes. Okay, let's attack this one first. How did you approach this question? Common factors are?
Yeah.
Mm-hmm.
And then, you know, after everything cancels out, you're going to use that for the y equals
mx plus b?
It's
Yeah.
linear.
Yeah.
So you literally just look at the equation, see the y-intercept
Yeah.
is 1, so x plus 1.
Did everyone do that?
Yeah.
Yeah. So I know, I don't know if you started with looking at the line first and then adding the commons, or starting with the commons, then adding the line. How many people started with the common factors first with the holes? Okay, let's do that. So I know it's y equals. Okay, let's do the holes first. So what do I have? X at 2. So I have x minus 2, top and bottom. And then negative 4. So x plus 4. Okay, I got my holes taken care of. So once they cancel out, I still have to have a linear. So this linear equation is what? The y-intercept is 1. This is my work. And my slope is 1. Yeah, up 1 over 1 or up 2 over 2. Okay, so that would just be 1x plus 1, right? That's the equation of the line. So that's what I have to be left with. So I have to be left with an x plus 1. You good? Great. That was great if you got it, because that's something you haven't seen before. Same thing here. Okay, so I have common factors at what? Negative 3 and positive 1. Okay, so x plus 3, x minus 1, top and bottom. Okay, now I have to be left with a quadratic. So this is a fairly easy one, I think, because it's centered on the y-axis, right? So it's really just a normal one, an x squared, moved down. As long as the stretch is okay, let's see what, it should be up 1 over 1, and it is, or up over 2, up 4. Yeah, which is, so it's just a regular x squared shifted down, minus 4, right? Perfect. How many people got that one? Excellent. Right? How did you do it?
I did it like, I wrote it kind of like, you know how it has what's it called? Slope compared,
The graphing form?
yeah, like not like ax squared plus bx plus c, but
Yeah.
the other form where it's
Yeah.
set form.
Yeah.
I did that and I solved for 8 and I realized it was.
Oh, I see, so you did this way, y equals x minus 0 squared minus 4, something like that?
Yeah, it's the exact same thing.
Perfect, yeah. And what happens, because you know your vertex is at 0, -4, so then you solve for you put a point in, perfect, yeah. Good. Okay, I don't want to, like I said, there are a lot of people taking their time with the graphing or who are still working the skills, so I'm going to let you keep, maybe we'll do one graph before you go, I don't know, but I'm going to let you guys keep working on the graphing. Because that's what all this beginning stuff really is, when you're forced to work backwards and make up the equation, that helps you understand when you start moving forward again, which is what we're doing here. So now you're given the equations. I tried to do a variety of different stuff, so you kind of be exposed to different types. And again, the instructions say you're looking for asymptotes, points of discontinuity, which are also called holes, and intercepts. Because if you do it properly, if you identify your asymptotes and your intercepts, you should have to do very little point plotting. You shouldn't have to make tables of values for each one of these things. So I'm going to give you some time, and hopefully we can do one or two before you go. For homework, I'm not going to assign any questions to do, but I'm going to assign you reading again. And so if you finish, I guess you can do some reading too. I'm going to get you to do read pages 123 to 124 in the textbook. It starts talking about rational equations, which you haven't seen since last year.